Okay, this is 4.5, question 13, and it says determine the x values. I might pause and just write this down for you. Okay, so it says for which these two functions, I don't like that they name them both f, so I'm going to put f1 and f2 just to be really clear. We want the gradients to be equal. So I'm going to take the gradient of f1. When I do that, I get 2x, and when I take the gradient of f2, I get -2 sine 2x. Okay, so that's probably the easy part. Now when I set those equal to each other, that's the first time when I have to really think about what I'm going to do. And when I have sine and cos in the same equation, I always turn it into tan. So I have to remember, I'll put my little things that I have to remember over here, that sine theta over cos theta equals tan theta. So that's one fact. So I'm going to divide both sides by 2 cos 2x. And that over here gives me 1. And over here it gives me negative tan 2x. And I might make this -1 equals, getting to the bottom there, tan 2x. Now, when I have the situation where I have, something other than just plain old x in there, I have to change my domain. So the second little fact here is that if my domain for x was from -pi to pi, then my domain for 2x has to be double that. Okay, so I have to say that, and that's something that people forget all the time, so we got to remember that. So when I'm solving this, I'm going to make sure that I find all the places where 2x can be -2 pi to 2 pi. So I expand my domain because I've expanded that angle. Okay, so now I have to figure out where is tan theta equal to 1? -1, sorry. And so tan theta is negative here and here, and it's where sine and cos are equal. So it's pi on 4. So negative pi on 4 there. Now I'm going to go all the way around, and this, I reckon right there, is 1 pi on 4, 2 pi on 4, 3 pi on 4. Okay, so let's write down what all my x's could be. I could have x being equal to negative pi on 4, or all the way up to here. Well, that's negative 4 pi on 4, so that's negative 5 pi on 4. And then this one we just said was 3 pi on 4. And then all the way down there, well, this is 8 pi on 4 because it's 2 pi, so 1 back would be 7 pi on 4. All right, that's what 2x, equals 2x. Now once I've got all those, that's the really big trick, getting all 4 of those. Now I have to divide by 2, and dividing by 2 means just multiplying the denominator by 2. So I get x equals negative pi on 8, negative 5 pi on 8, 3 pi on 8, and 7 pi on 8. So there's a lot to remember here, okay? The first thing is, when you have cos and sine in the same trig equation, it always turns out to be a tan equation. Isolating the tan actually means getting that negative over there. Then this big deal, which I couldn't really do before because it was going to smear all over the place. But when I have, an angle that's bigger than just plain old x, I have to expand my domain, and then I go down, to get these values after I have expanded. And I think that's it. Okay.